Recording officially started. That means the show has started. So welcome back. More folks joining in person and on Zoom. Excellent. I have open a few different things. We're going to go over the bridge activity 1 that closed last night. This morning I turned on the settings, hopefully, so you can see your scores, what the correct answers should have been. And I'm going to go through them one by one, and we can talk about why the answers are the way they are. No one got 100.
Yay!
All right? So we're going to talk
we all
about
have room
this.
to learn.
Yeah, it's good. It's good to know that. So that was one of the pieces of feedback that I got last semester, is people were thinking they were the only ones that didn't understand something, made them a little shy. It'd be nice if I could do something that would tell folks what the climate is in terms of how well folks are following. And so yeah, here's your distribution. So looks like the modal is 50%. So I don't really care about right or wrong. I'm more interested in you looking at what you did and understanding why it was wrong, so that you can generalize and solve the problem differently next time. So please do not hesitate to ask questions, or if you think my answer key is wrong, even, you can tell me that, because I'm imperfect and that sometimes happens. Had a question earlier, and I had the same question here. I was going to say, folks who are in person, if you need to eat while you're in class, I'm totally fine with that. Zoomers, of course, can eat all you want. I don't even have to watch you eat if you don't want me to. Just don't spill on the computers and get me in trouble is the only thing I would say. Because that's where they would care.
Thank you.
So absolutely, food is important. So we have that to do today. We're going to start lecture 2 today. I'm working on example 2A still, so that probably, I don't know if we're going to start it on Wednesday, or not Wednesday. We're definitely not starting it on Wednesday. Not sure if we're going to start it on Thursday, but I do want to remind folks that we are being kicked out of our classroom on Thursday, so we're moving to Zoom only for that. Ding, ding. And I also put up your first formative assessment.
Woo-hoo.
We have, hang on here. Okay, 1 second. So these are, you get 2 points for doing them, regardless. Good faith effort. We'll go over the answers in class, and by we, I mean Vladimir will. So he's going to lead the discussion to review these things. So I have the questions up here so that I can go over them if need be. But the first question is, are there any topics that you want to review more? So explicitly asking for a prompt of anything you want to talk about. And then an essay question, and then some equation stuff, more practice with interactions and how to think about getting what the slope would be for any value of a moderator. So that's what those are. And then there's one more at the end, which merits a little bit of explanation if you don't know me. One of the things that I like to do to get to know folks, and also to expand my musical repertoire, is to ask each of you to give me what you think your theme song would be. So a theme song, otherwise known as walk-up music, like if you're going to step into the game or the arena, what's playing on the overhead to mark your arrival? That's what I want to know. So if you're willing, if you would provide a link to YouTube where the song is, I will build a class playlist, and you can explore each other's theme songs, to be unlisted, but I think it's fun to see what pops up every semester. And I've found some good music that way. So it does not have to be in English. It can have lots of profanity. I really don't care. Obviously, I say shit a lot in here. So anything that you'd like to do with that, have fun with it. So this will be due next Monday, and we'll go over it on Tuesday. Any questions on that? No.
I do have one.
Yeah.
Based upon our earlier discussion, are you going to try to get the equation to be visible? Because it was mentioned earlier that an equation was not showing up.
It looks like it's visible now.
Okay.
So it wasn't visible in the preview mode, but this is in the edit mode.
Okay.
So
All right. Sorry.
No worries. I just, what I can do is like view as student and then see what it looks like from your perspective. And they should be, now it's not rendering? Okay. I will fix it. Okay. I will make this visible, but there are equations in here based on the model. So I'm not sure if it's the rendering or they're not there. But if one of you could log in and check it for me to see what you see on your end, that would be helpful. Because
This
if
is a multiple, take as many as you want to.
yes, it is.
This
Yeah,
one is,
it's 2 points for making an effort,
Mhm.
and if you change your mind and want to resubmit, you can. But I don't believe the system has memory. So whatever you type and submit will not be stored and editable. So for that reason, it would be good to save your answers offline and then just paste them in. That way you have have a record
I
of that.
also do not have equations showing on my end.
Okay, then I will find a way to fix that. Zoomers say the same thing. All right, my bad, but I will get that fixed, I promise.
No worries.
Yep. And then the next thing after that is another bridge activity designed to get you ready for homework 1, and I will let you know when those things are available. All right, so that's that. So I have up here the output from the model that is based on the first 5 questions or so that we can look at the numbers, and then we'll go through the questions one by one and see what the right answer should have been and why. So the first one, and by the way, I had these randomly ordered across you, so where the answers are is not the same.
Mm-hmm.
So if you picked like the second one, that may not be the second one that I'm showing. So the fixed intercept, the story here, based on a true story about mini golf. So the story behind the story, as it were. When my husband and I were first dating, and the first time I went to California to meet his family, we went mini golfing with his sisters. And up to this point, he had been sort of mild-mannered, easygoing. He talked so much trash to his family during the mini golf game, like it was cutthroat. They took this stuff very seriously. So I made a story about the importance of experience and enthusiasm in playing mini golf. And then the next time I went was with my family. And my dad, who likes to play real golf, was not doing well, and he blamed it on the mini golf interfering, like his regular golf game interfered. So that became the other half of the story. So in this hypothetical experiment, we have randomly assigned people to a control group, which is whatever, a group that gets mini golf training specifically, so that's what C versus M is meant to indicate, a group that gets regular golf training only, CVR, so control versus regular, and then a group that gets both kinds of treatment simultaneously, CVB. And then I have enthusiasm measured on a standardized scale, and I have experience centered at 4 on also another, like a Likert scale type of thing. So this model is what I would call a main effects only model. It does not have any interaction terms. And this, for the most part, went fairly well, I think. So first question then, what is the fixed intercept of 75? The rule is the intercept is always the expected outcome, which is your score on a high-stakes round of mini golf at the completion of your training, for somebody in the reference group, meaning at the 0 value of each of these predictors. So that would be enthusiasm of 0, experience of 4. I name my predictors with the constant they're centered at, so that I don't have to remember that. And then the control group, because that's when each of these variables would be coded 0. So that's why the correct answer is this one, the expected golf score for someone in the control group with enthusiasm 0 and experience 4, which most folks came to that conclusion. So distractors, the intercept is the expected golf score on average. That would only be true in, I can think of 2 cases. One is that you have an empty model, meaning there is nothing predicting it. So the mean is the best answer for what each person's score is. So beta 0 would just give you the average golf score in that case. Or your predictors were all centered at exactly the sample mean, so that it worked out that it was the average of the group. That is not true in this case, unequivocally. So that's why that's not the right answer. And it's also not on average across the groups because of the coding scheme. So if I had used effect coding, where there's a pattern of -1s, 0s, and 1s, that is designed to yield the average across groups. I chose to use a coding scheme in which the control is the reference, and each of these slopes tells me how the other group differs from control. So those are choices. There's nothing wrong with setting up your model differently necessarily, but it's internally consistent in terms of what it means this way. And this one was a distractor that was terrible because it's about the both golf group and no one picked it. So good job. Next one, how would you interpret the fixed slope of enthusiasm? Back here. So enthusiasm has a slope of -5. So that automatically rules out some of these combinations. A negative slope means that as x goes up, y goes down. So we know that golf scores are going to have to go down as a function of higher enthusiasm. And I have in parentheses what that means in this context.
Thank you.
So in the game of golf, high is bad. It means you took a lot of tries to get the ball in the hole. As few tries as possible wins. And I know that is counterintuitive in some respects if you're not a golfer, which I am not. But there are many outcomes that people are interested in that are bad things. People studying crime or disease or illness or abuse. Like there's a lot of things you want less of in life. So you can think of it as that context. So the fixed slope of enthusiasm, for every unit higher golf is, enthusiasm is lower by this much. Now, why is this wrong? Yeah, this is switching which is X and which is Y. So the number up always talks about what happens to the outcome as a 1 unit change in the predictor. So this is wrong because it's backwards. The other two are wrong because they're backwards in direction, or they're backwards in X and Y as well. So like the wrongest one is the one that no one picked here. For every unit higher golf, enthusiasm is higher by 5.3. So that switches what X and Y is, and it also switches the direction. So this is the correct answer, which most folks got. Okay, with me so far?
Mm-hmm.
Next one, how would I interpret the fixed slope of CVR? Well, in this case, let me go back up, there we go. Trying to get everything on the screen at the same time. It is a positive 4. So that means that people who are in the comparison group, which is the regular golf training only, are higher than the reference group, which is control, by 4.7. So in terms of the choices, this is right because it gets higher correct, and because we're talking about regular being higher by 4.7 relative to control. So the other ones here that get it wrong, let's see here, the mean golf score in the control group is higher than that one. That switches the groups around, so the slope would have to be negative for that to actually be true. The mean golf score in the regular group is this much. No one picked that, but that is a common misconception I've seen in these sorts of things. This is not the mean for the alternative group. It is a mean difference relative to a reference group, always. And then the mean golf score in the regular group is lower, gets the direction wrong as well. So this one went reasonably okay as well. And then this one, a little trickier. This is why we're doing this. So the question was, numerically, meaning don't try to get a p-value out of it, just look at the numbers. Which of the following is true about the incremental effect of regular golf training beyond mini golf training? So this is asking you to put the context of the story to compare two of the slopes. So the incremental effect of regular golf beyond mini golf would be evidenced by comparing the both group, which got both, to the group that only got mini. Because what differs then is the regular golf addition. So we're comparing CVM, which is -10, and CVB, which is -5. Okay, does that much make sense? We're looking at the incremental addition of regular golf training beyond mini golf. So CVM and CVB both got mini. Only CVB got regular too. Now these are slopes relative to a control group. So mini golf helped by 10. Mini golf and regular golf only helped by 5. And I'm saying helped because negative is good in this case. We're reducing the number of strokes it takes to finish the course. So my guess is that folks who picked the distractors did not understand which groups were to be compared. That's a very easy mistake to make. But the correct answer is that adding regular golf training, meaning the both group, is less helpful. So I would say it's still helpful because the score is still lower in the both group than the control group. But it is less helpful because it's only lower by 5 instead of 10. So this is the aforementioned interference effect, that being trained in regular golf messes up your mini golf game, according to my dad. That's his excuse, and I'm going with it.
Question.
Yes.
If the CVB was positive 5.38 as
Mhm.
opposed to negative, would that change your answer?
Yes.
Would it be more harmful then?
I'd have to reword the question entirely if this were a positive number, because one is harmful and one is helpful,
Okay.
and then I'd
Okay.
Yeah.
No, that's okay. I'm
Yeah.
just curious.
Yeah, the more or less thing is like within the same direction, I would say.
Right.
Yeah.
Okay. Thank you.
Yep, no problem. So then adding regular golf is more helpful. I would say that is wrong because neither of these are actually more helpful would be the opposite pattern. It would be like a negative 10 here and a negative 5 here instead. So the both group would have to improve more as a result of adding the regular golf. Adding regular golf is more harmful. So that also doesn't work because it's a reduced effect and it's not harmful at all. So folks who picked the other answers, are we feeling like you understand what I meant? It's a little bit of a convoluted question. And to be fair, Vladimir asked me about this question too when he did this. So, yeah. If you ever read a question that I write in anything and you're like, what the hell does she mean? Just send me an email that says that and I'll try to clarify as best I can. This isn't supposed to be an English class. Okay, any questions on this? All right, then we're going to scroll on down in my tiny little window here. There we go. To the interaction model. So I printed in here both R and stata output in case you're used to looking at only one versus the other, but the R output is bigger, so I was going to stick with that. It's a little more visible. So the intercept is first, otherwise the tables are pretty much identical. So this is an interaction model. And there's a lot more variability in the responses after this point, as you might imagine, because this is much more complicated. So what I have added are 3 new terms that conceptually map onto one idea. We are looking at how experience moderates the effect of training. That's the idea. But to do so, because the effect of training is represented by 3 slopes, we need 3 interactions to examine moderation. If we had training represented by only 2 slopes, then we need 2 interactions instead of 3. So it follows logically with however many slopes you need to differentiate your groups as a main effect, you need that many to differentiate your moderation across groups as well. So these 3 new terms I can talk about as how experience affects the impact of training. I can go that way. Or I could go the other way, is the effect of experience differ depending on which group you're in. So either is correct. The first way probably makes a little more sense. So then we get into it. Which of the following is true about the fixed slopes for golf group differences? So we're referring to CVM, CVR, and CVB here as main effects. So the correct answer, they describe unique effects. That's in all 4. What does the word unique mean? What do I mean by that again? When I say a unique effect as opposed to like a bivariate effect? Yes, there are multiple predictors in the model. The slope for each describes what each one brings uniquely that the other ones do not in predicting the outcome. That's what unique means. Any overlap in how predictors relate to y across predictors gets credited in the R-square for the model, but any individual slope does not get credit for the overlap. Yep. The amount of variance that a term would reduce, like the interaction, it counts the overlap, because that's asking how much of the R-square would be allocated to this new term. So yeah, but each of the slopes is the unique effect controlling for, adjusting for, or holding constant. Those are all synonyms that you'll hear for what unique means. It's just fewer words, so that's why I say it. All right, questions on that? So that everything is unique, that's it. Then we get here, how control differs from each training. That's in the next variation. How training differs from control, how training differs from control. So why is it this way? Why do I have to say how training differs from control and not the reverse? Control is the reference. So when I think about these slopes generating a predicted outcome, if I'm talking about the control group, none of these are activated. They're all 0 for all of this. So these numbers apply to the other group. Control stays the same. So that's why it has to be how each training differs from control, because that's when these terms turn on, and start adjusting the score based on which group you're in. So the unique effects, how training differs from control, and then after adjusting for, that's sort of redundant with unique, but I wanted to throw that in there, or holding constant, enthusiasm, and experience. All right. I'm looking at that and I'm saying, that's not right. There's a problem in my answer key.
I was going to say because
Yep.
because experience has to be 0 for the others to drop out, do they not, for the interactions to drop out?
That's my question. Now I'm looking at, is this tied to the other model? Because otherwise my answer key is wrong. I need to go back to the question. Vladimir, can you check it out for me, please?
Yeah, of course.
Is this the main effects model or the interaction model? It feels like it should be the interaction model, because if so, then my answer key is wrong. See, it's a good thing we're going over this.
So which one is it? Which one do you think or are you just going to go back and rethink? And I'm okay with that.
What I'm reacting to is if it's this model, these are simple effects conditional on experience of 4 because of the
That's what I'm
interaction
looking at,
terms.
too.
Yep. And there isn't an analog for that combination in here. So this would be the right answer from the main effects model. And so that's why I want to check which one it goes with.
Well, it says golf group differences at the top.
Yes, but they're both.
That's question 5, section 1.
Section 1. Okay, thank goodness. I'm doubting my own self. I thought I was moving on to the next one. So yes, before adding the interaction terms, that is true. My answer key is correct.
Okay.
But I'm foreshadowing where I'm going, though. All right, so sorry for the confusion. Let me reiterate. This answer, this is question 5, you said?
Yes.
That is tied to the other model, the one in which there are no interaction terms. And so these are unique effects, but they hold regardless of enthusiasm and regardless of experience. Now we're in the other model. Okay, does that make sense?
Okay. Yes.
Okay, good.
I may have looked at the wrong
Yeah,
thing
I
when
don't
was going
understand
to-
why it's like not showing the rest of the question, because that's a separate question you have to scroll back to, so.
Oh, yeah.
Yeah.
Cool.
How would you interpret the fixed slope of enthusiasm from this new interaction model?
Mhm.
So we have 5.251 is the coefficient, 5.25-ish. So we have golf scores are lower by this for every unit higher enthusiasm for persons in the control group as a choice. We have lower for every unit higher enthusiasm in persons whose experience equals 4. And so very few people picked those answers. The next most popular one was lower by 5.2 for every unit higher enthusiasm for persons in the control group whose experience equals 4. And the right answer is not conditional. So the reason enthusiasm, golf scores are lower, better by 5.25 per unit higher enthusiasm. Doesn't need to say for this kind of person in that group or anything. Why?
Only referring to enthusiasm. It's centered.
Say it again.
It's only referring to enthusiasm.
It's only referring to enthusiasm, yes, and there's only one spot for enthusiasm.
Enthusiasm is not interacting with any
That's
other,
it.
or being moderated with, or however you want to.
Exactly. Enthusiasm is not part of these interaction terms. That's why. So it's not conditional on anything. For every unit more enthusiastic you are about playing mini golf, you do better by 5.2 strokes. The end. Enthusiasm matters. If you lose your will to live during the mini golf and just start whacking it, bad things happen. Not that I do that. Mini golf is back open at the bowling alley in South Iowa City again. I've mentioned the bowling alley because my son's in a bowling league every Saturday morning, and it's under new ownership. So they've moved it from like 1985 up to about the year 2000 now. So they've redone things, and they've improved the mini golf course and made it so that if you do hit the ball, you're not going to hit a bowler on the other side. So there's a wall.
Wow, that's nice.
Yeah, it's a good feature, I think. But their mini golf is $5, and they have pins as obstacles on the course. It's cute, But my son likes to go there, so I end up whacking things at some point, just being frustrated. But anywho, so this one, question number 6, tied to this model. Enthusiasm slope is not part of an interaction, therefore this effect is unique, but it's marginal. It holds for everyone. There. So then, well-intentioned folks said, whose experience is for? Because they're like, well, everything else seems to be an experience, but it's not interacting. Not in this case. So that's why. Okay, questions? All right. How would you interpret the fixed slope for experience? Okay, so that's right here. This is a different situation. Because of these interaction terms, the slope of negative 2.2 only applies to describe the effective experience when everything else drops out that it's tied to. When is that going to happen? My question for y'all. When are these 3 interaction terms going to drop out and not contribute anything to the model? When experience is 4, or, in this context,
Group is used, the control group
yeah,
is
when you're
0.
talking about the control group. So we're focusing on the slope of experience as group is the moderator in this, like flipping it the other way. So the only situation in which the 2.2 is all you need is when these things go away, and they only go away if we're talking about the C group, control group. And so these drop out. So the correct answer then, golf scores are lower because the slope is negative by that much for persons in the control group specifically. Now, a lot of folks liked that idea of conditioning on the control group and then also conditioned on enthusiasm. Now, why is that not correct? Exactly. Enthusiasm does not moderate experience. That would be enthusiasm by experience in order to make it doubly conditional. Yep. And forgetting the conditional, or folks who picked this answer, it looks like, forgot that it's for the control group. That's an easy thing to do. The reason that I make such a big deal out of this, though, is because I see this in published work a lot. People put interaction terms in their model and they forget that the other things have to change what they mean. So what if I had a non-significant slope of experience and I'm like, look, it doesn't matter. I'm going to write a whole paper about that, and my discussion is going to talk about how all the research saying experience is helpful is wrong. Well, that's not the correct interpretation of this slope. This is experience. Doesn't matter in the control group. These interaction terms are going to change what the effective experience is in the other group. I got to know what it is in each group in order to say, does it matter or does it not? Or does it matter for some people and not other people? Then that's a much more nuanced story, but that's the world we live in. Things are complicated. Individual differences. All right, questions on that one? So recapping, enthusiasm, that slope is unconditional, meaning it's not for the control group and not for experience 4 because enthusiasm does not interact. The slope for experience is conditional because it's part of 3 interaction terms, so this is the slope of experience specifically for the control group. Then we get into these ones. I'm like, did I do that one next? I hope I did. Yeah, that would make sense. Which of the following is true about the fixed slopes for golf group differences in this new model? Okay, so same idea. Golf group differences are these three ones in the middle here, the C versus whatever. But they show up in another place too. So then these are only the golf group differences if what happens to the interaction terms? They go away. How does that happen?
Oh.
So this was the
Oh,
way
wait,
that you
oh,
went
something.
previously.
Experience.
Yeah,
Experience is 4.
if experience is 4.
Right.
Yeah,
right,
that's
right,
when the
right.
last three terms describing group stuff drop out, and the group stuff is right here only. And so we have 18% got that right. So it's the flip of what we just said. So unique effects of how training differs from control. So we got the direction right in terms of training as the alternative reference, or control as the reference, specifically for persons whose experience is 4, because then that's when these go away. So next popular answer, describing how training differs from control, forgetting the fact that it's conditional on the interaction terms. No one picked the bad distractor, enthusiasm of 0, good. I was just in a dissertation this morning for someone who was focusing on nominal response models and item response theory in the context of analyzing whether you picked which distractor as a further indication of your trait or ability level. So these kinds of models are actually like what this is based on is a real thing. So I tried to write distractors that would target certain patterns of error so that we could talk about those patterns. So this one would be a very bad distractor because this is not a plausible alternative. But I was out of ideas and I had to come up with something.
Could have gone with 3.
I could. I know, but I wanted to keep it even. I don't know why that matters, but it does. 4 is like the sweet spot because more than that, there's too many damn choices. And fewer than that, it's easy to get it right by chance. So then the next popular response, actually the most popular, was to condition on both variables, which seems like a reasonable thing, except that enthusiasm doesn't interact, and so it's not conditional. All right, interaction time. Which of the following is true about the interaction of experience and CVM? All right, so I looked through the choices, and I'm talking about the effect of training and how that changes by experience. So that means I need to focus on training as like the root thing I'm caring about, and then talk about experience moderating that. So I'm focused on the -9 and the -3.8. So right away, the number signs match. What does that tell you?
Cancel out as a positive.
They're both negative in this case. So you're adding 2 negatives together.
You're multiplying.
Oh, I'm sorry.
Yeah, no worries. Yeah, in this case, because you're multiplying a variable, but you're adding, like, you're essentially adding the contribution of those variables. So if the signs match, the interaction term is making the effect stronger. If the signs don't match, it's making it weaker. Those are the 2 kinds. Then we get into the more positive, less positive, more negative, less negative. So in this context, the effect of training in mini golf reduces your golf score, makes it better by about 9. That's a benefit. So I'm zeroing in then harmful versus beneficial. I'm focusing on the fact that a negative slope is a good thing in this context. It's a benefit. So that tells me right away that these 2 are the only possibilities. And then for every unit greater experience, does that benefit get stronger or weaker? So what would happen is if experience were 5, it would be -9 plus -3.8. So then it's more beneficial in people who have higher experience. People with greater experience are better able to utilize the training, perhaps. You can see things like that play out in other contexts of training and instruction as well. So that's where it is. Harmful would be in a context in which more is better instead. So the idea of benefit versus harm is tied to whether a good thing happens if the outcome goes up or down. So it looks like the most popular alternative was beneficial still because they've recognized the minus, but then got the direction wrong. Easy to do, especially when you're looking at a large table of numbers. What about, let's see, yep, thought I had another one. Is this the last one? Yep, the last one. What about the interaction of experience by control versus regular? So we're talking again about the effects of training, so experience as the moderator. So regular, is being exposed to regular golf helpful or harmful to your mini golf? Like this one right here, the +5.
Harmful.
Yeah, harmful. It makes your score worse. Takes you 5 more strokes to finish the game. So then what happens as a function of experience? So we're comparing the 5 and the -9 here. Opposite signs. Yep, I'll take gestures.
I don't know if I can verbalize what it means.
Yeah,
Like,
no, this happens.
It's like the opposite.
Yeah, exactly right. There are some things that you just need gestures for, and I do that quite a bit. But yeah, so I would say less harmful because that 5 is being reduced per unit of experience. It goes down to about 4, and then it would go down to about 3 because the interaction term is a -1. So for every unit greater experience, the harmful effect is weaker by the interaction term. And looks like that was the most picked answer. Yeah. So what this tells me is that with practice, y'all grow a lot. So we'll keep practicing. Believe it or not, this used to be, in the previous semesters of this class, a homework assignment doing all of these, and it was very long and convoluted. And I decided to scrap it in exchange for doing it this way and making room for a few more of these activities so that we could focus on the generalized component that this class is supposed to be about. But Vladimir, you did the golf homework. Should they be grateful I didn't make them do it? I think so. He's like, and I'm grateful
for
too.
this class or the golf homework that we did last semester?
Yes.
That was an interesting one.
So the golf homework you did last semester, if you were an intermediate, was the main effects version of this model without the interaction terms. So I didn't have experience and enthusiasm, I think, in the same model in that unit. So it's the same story, but a much simpler version. Yeah, you'll see that if you take repeated classes, like I'll borrow homeworks from other classes and simplify it or make it harder to make it work for that class. So that's the last one. All right, so in Icon, you can see how many points out of 2 you got for answering accurately. To that, I added a constant of 3 for everyone who answered the questions. And so in the homework portal, when you log in, you'll see your current totals. It includes the 3. So these activities are worth 5 maximum. If you didn't turn it in on time, though, it's only worth 3 maximum because the answer key is already revealed and discussed. So then it's less fun since you know what to do. Okay, questions on any of that? Zoomers have been quiet today. Can we do a thumb check? Does this make more sense now that we've talked about it than it did? Because that's what I'm going for, is more sense, heading in the right direction. Maybe not completely sensical, but more. Yes?
I'm just trying to solidify.
Good.
I think the part that I'm struggling with to interpret is when you have I think, do we call it a simple effect of a predictor that later has an interaction added, then that effect is specific to when the interaction term is 0.
Yes. Yes. So let me repeat that. So in the same model, like in this model, for example, the term for these, I call them simple main effects or simple slopes or simple effects. That's what people call them. The idea is that they're conditional. So I would say, yes, this is the experience effect specifically in the control group. This is the group difference specifically for experience of 4. And then the interaction terms are unconditional because they moderate the same way for everyone. Okay, did that help?
That's what I mixed up when I was answering. I think I put the specific to 0 or specific to 4 for the interaction terms, not the simple terms. Flip that.
Yeah. So the interactions like change what these slopes are. And so that means their definition is only that when the interaction terms don't change it, which is when they're knocked out by the other predictor being 0. That's the tricky part. It's like the other one. And if group also interacted with enthusiasm in this model, then I would have to say these are group differences at enthusiasm equals 0 and experience equals 4, because it's both conditional. Yep. Okay, questions from the Zoomers saying glad it did help. Great.
This was very beneficial.
Let's see. Also glad with many folks had things in common with me. Getting certain ones wrong as a majority. Yep. Will we have an opportunity to complete one more retroactive review type assignment, or will this be a standalone? So, great question. I have to make the next one. I haven't started. So, what I was originally thinking is that I would make it sort of like mostly focused on the new stuff that we'll be doing over the next week or two. But what I can do is maybe throw in a little more of this and then a little more of the new stuff, so we can kind of bridge the bridges. If is that a thing?
You're making a spanning bridge.
Yeah. So the good news, if you want to call it that, is that we're going to do this the rest of the semester. Because these rules, these principles, these labels, these concepts do not change, regardless of what kind of model. Anywhere from simple regression all the way up to structural equation modeling and anything that's super complicated, these are the same principles. So when we're predicting a binary outcome, we're going to talk about the slopes as predicting a transformation of what's to be predicted, a link function, a logit, the thing I'm going to tell you about, but we're not changing the way we interpret the slopes. Once you change what y is, everything else stays the same. So I think it will actually be easier to bridge the bridges because of that. And yes, if you didn't get everything right, that's all of you.
Yay.
And that's totally fine. What I'm aiming for is mastery, and that does not happen overnight. It happens at different rates for different folks based on a lot of different things, and all I care about is that by the end of the semester, you feel like you have a handle on this, and you can use it in your work. And if that doesn't happen by the end of the semester, then maybe someday. Keep working on it. Okay, other questions? All right, then I'm going to shut this down. I think we actually have some of lecture 1 to finish. I think I got too excited that we're going to start something new today.
I thought you wrapped up. Like with there were like.
I think we're doing, yeah, we didn't finish the interaction
Did
terms.
we not? Oh.
So yes, we are going to keep reviewing, just not with multiple choice questions unless I pose them spontaneously. So we talked about the 4 kinds, which there's only 2 now. When there's more than one interaction, I think that's where we left off. That's my memory. Can anyone confirm or deny? Deny. There's an extra R in there. Vladimir, does that sound right to you?
We talked about it a little bit. I'm also might be blending with last semester.
Yeah, these are recycled slides.
So my brain is not a good reference.
Yeah, this is like kind of a greatest hits collection of the intermediate class to start off with. Let's slide 22 in lecture 1. That's where we're going to pick up.
Sounds good.
So when there's more than one interaction, this is what you get to practice on your formative assessment that's due on Monday, these sorts of concepts. So I'm just using generic letters for variables here to keep the story simple, but you can think of these as enthusiasm or training group or whatever you care about in your world. So in this example, I have 3 predictors. They each have what I would call main effects or simple main effects, meaning what is it like just for W alone, just for X alone, just for Z alone. But then we also have two-way interactions. So we have X and Z for one of them, and W and Z for the other. So this is a more complex version of what we just saw, but the rules are the same. So in talking about the effect of W, I have to say specifically when Z is 0, because W shows up here, and beta 1 is only the slope of W all by itself if the interaction term goes away. When that goes away is when Z is 0. Same thing for X, because I have X and Z right here. The slope of X is in 2 places. Beta 2 is the only time beta 2 is the only slope that's relevant is when this goes away, and that happens when Z is 0. So that much we've seen before. Now here's the new one. Z. Z is in 3 things.
Boy.
So I have to condition on both, because I have to make both interaction terms go away in order for beta 3 to be the only thing that controls the slope of z. So I have to say when w is 0 and x is 0 at the same time. The interaction slopes, I would still say, are unique marginal, meaning they're after controlling for the other stuff, but they hold for everybody. So beta 4 is how the slope of x changes as a function of z, or how z, the slope of z, changes as a function of x. You can think about it from either direction, and the same would be true for beta 5.
So with the interaction before beta 4, we can interpret it both ways.
Yes, every two-way interaction has two equally correct versions of talking about it. Mathematically, it's not a distinction. It's a distinction in terms of interpretation and what you care about, because usually one variable is like the moderator and the other variable is the thing the paper's about. And I would phrase it according to what your message is going to be. So then, trying to figure out how the model says what the slope of x or w or z would be is a little more complicated, but totally doable. So there is a 3-step process. Number 1, find all the terms that have the variable the slope is 4. So if I'm talking about w, I need beta 1 and I need beta 5. So I'm going to bring those two down. Ignore the rest, because the rest of them aren't talking about w. They're irrelevant to the question. I then factor out the variable the slope is 4, which is w, and that's going to go in the back here. And so then what's left in the brackets is the recipe for how the model tells me for any value of z what the slope of w would be. So this shows a little more directly why it is that beta 1 is specific to z being 0, because then that's where the interaction effect drops away. Same thing with the effect of x, same premise. But note then we're switching the interaction term and we're switching the beta 2 because that goes with x. So in your formative assessment, I gave you an equation that doesn't render apparently, but I gave you one and I will figure out how to get it to you again, and then asked, like, how, given these values of the moderator, how would you find the slope? This is the logic I'm looking for in your answer. We will go over how to make the computer do this semester, as we did last semester, if you were with me. The effect of z then, z shows up in 3 places. So all 3 of them come down here. We factor out z, and then what's left is this ingredients here. So this shows then that beta 3 can only be the slope of z when these things go away, if they're both 0. But I can figure out what the effect of z would be for any x and for any w with this equation. So for quantitative moderators, there is a technique I showed last semester. We're not going to spend time on it, but I wanted to put it out there, called regions of significance. Because you might want to know, like, well, at what point of x does the slope shut off? And what point does it turn back on again? Because non-parallel lines are created by interaction terms. So this is a technique that allows you to compute, essentially, what are the ranges of your moderators at which your slope is significant or non-significant. All right, categorical predictors then. Same premise, that's what we just did, except with a different story. So if I have control in 3 different kinds of treatments, it was a golf story, but this is a little more generic, and I want to know if the effect of treatment depends on how old you are. This is an aging study, so I have age centered at 85 years. This is a gerontological setting. Well, that model looks a little ugly. It's what you just did, though. So we have main effects of group, which are these D1, D2, D2, D3 for the differences between how the treatment group differs from control. A main effect of age, centered at 85. And then if I want to know if the effect of age varies by group or the effect of group varies by age, I can say it either way, then I have 3 interaction terms in here. So then to answer the question about whether age moderates the effect of group, I would need a hypothesis test for all 3 of these at the same time. The group difference slopes are then conditional on age 85 because beta 1, 2, and 3 only control the group differences when the interaction terms goes away. That happens at age 85. The age slope also, this is specific to the control group because that's the point at which these interaction terms go away for it. It's the reverse. But the model tells you what the differences between the groups would be, regardless of whether you're talking about treatments or control, and for any age. It tells you. Right, Rebecca? She came to office hours yesterday with the exact same problem, almost. So I worked this out for you to show you the logic. So if I'm talking about the slope of age, then I got to find all the places where age is in my equation. So beta 4 is the start of each of these. That's the age slope. And then I turn on the interaction terms with a 1 when I'm talking about that group. So for the control group, they all shut off, and I'm left with just beta 4. For the treatment group, the first one turns on, the other two are off, and so on. So this would tell me then how the effective age is in each separate group. I can also get differences between groups for any age the same way by plugging in just the relevant interaction term that controls that group. And I can get the alternative group differences if I follow the logic. So, there for complexity.
Sorry, Lisa, I have a
Yeah.
question. Yeah, on this page, in this model, we have 7 betas. But in the zeros and ones at the top, there's only like 4 numbers in a row. Shouldn't we have 7? And then beta 0 is 0, beta 1 is 0, beta 2 is 0.
Okay. Yes, so the question was, why are these incomplete with respect to the zeros and ones? So I think it's a question of whether you're representing what you're doing conceptually or in code. So the reason that this is incomplete, I did not list every term, is because I'm focusing on the effective age, and the other terms are irrelevant. They would never contribute to it. Like if I'm talking about a slope, I'll never need the fixed intercept for that. And if I'm talking about the slope of age, I'll never need the main effects of group that have nothing to do with age. They'll never contribute. So that's why I've limited these to just the terms that could potentially contribute in each case.
So I think I found my mistake. I was looking at the zeros and ones at the top. That's your
Oh,
entire group.
Yeah, this is how I built these variables. That was what I was trying to show succinctly.
That makes sense.
Yes. But then to answer the question I thought you were asking, is in R, when you do these sorts of things, in GLHT is what we're going to use this semester as well, you have to fill in what you want to happen to every single term in the model. So you literally have to type, don't use this, don't use this, don't use this, and put a 0 in.
So there would be, like if I was coding for example, the first one, the effective age and control group,
Mm-hmm.
I would have 1, 2, 3, 4, 5, 6. How many zeros would I have?
As many as you have betas, so 8. 8 in total. So you would have a line of code. If you haven't seen this before, don't worry, I'll show it to you. There's a line of code where there's a spot that's separated by commas, and those are multipliers for what you want it to do to the slopes. So like the first one, it would be 0, 0, 0, 0, 1, 0, 0, 0. And the second one would be 0, 0, 0, 0, 1, and 1, 0, 0, and so on. But then you have to make sure that the way that you wrote your model and the way it shows up in the output is the same, because R will reorder your output to put the interactions last. And that changes where the zeros and ones go. Folks who are using either SAS or Stata, the command to do this kind of thing in Stata is either lincom, that stands for linear combination, or margins, using the dydx command. They don't require you to write a place for every single term that's in the model. You can just write the condensed version right here. So there's less typing involved in that and a little more transparency as well. So I know this is a little bit ugly, but I wanted to show you the logic of how the model tells you this regardless. Now, what I don't have on here are the differences. So there are 4 groups, right? There are 3 of the differences here. How many might I care about? How many differences are there possible pairwise for four groups? There's,
Four groups.
yeah, 6. Yeah, it's the, what, permutation rule or combination?
Combination.
Combination, I forget which one. I know there's exclamation points in it, that's what I know, in the math.
Factorials.
Yes, factorials. I always pronounce them as punctuation, though. Like 3, divided by 4. So there's 4 group differences, right? And these interaction terms tell us how the effective age differs, like in control versus this, control versus this, control versus this. But how many of those do you think there are? If there's only 3 here, how many are possible? There's 3 more. Yeah, there's 6 possible there. So that's the other piece of this, is that you're seeing only 3 of the 6 possible interactions that this model implies. Because the model also tells you how the slope of age differs between treatment 1 and treatment 2, treatment 1 and treatment 3. It's da-da-da-da-da. So there's more than what's even here that's possible. And I think in the last, I think it's example 5 of intermediate, I have more slides that did that, but I thought I would not belabor the point here. Where are we at? Almost done. What about three-way interactions? Could we do that? Yeah, we could. I did it in chapter 2 of my book to teach this stuff, and I went all the way up to a 4-way interaction to show you how to do that. I've seen one of those in my lifetime. And the person was begging for it to not be significant so they didn't have to talk about it.
So this work that you were doing for somebody else?
No, this is a student that's like, I don't know how to interpret this. It's like, okay, let's break it down.
What are the sample size expectations again for every time you add another level of interaction?
Interactions are much harder to detect than their corresponding main effects. So I think it would depend on the effect sizes you're trying to find. But yeah, you need bigger samples to have decent power to find interaction terms than you would just define the main effects. Absolutely. But my point in dealing with the students is, like, don't be afraid of it. Like, if it's there and it answers your research question, then you should report it. Now, whether it is significant and a trivial effect size, maybe that's a different argument, right? If you have a situation where you have a lot of power and everything's significant, then significant may not be the cutoff you want to use. You might want to think about only things that explain at least 1% of variance or something like that. You could make up a different standpoint. But three-way interactions. So the rule is you have to have all of the lower order possible terms for these things to be interpreted correctly. So if I have a 3-way interaction, that implies 3 2-ways, and each of those implies the corresponding main effects. So the rule is the same in terms of what interactions do. The simple main effects, meaning beta 1, 2, and 3, they make the outcome higher or lower. And each of these is conditional on the variables that it interacts with being 0. Each 2-way interaction takes the main effect slopes and makes them stronger or weaker because they become more or less positive or negative. If the signs match, they become stronger. If the signs don't match, they become weaker. And in this case, you're going to hate this, beta 4, 5, and 6 are simple 2-way interactions. Yeah. Like, is that not the biggest oxymoron you've ever heard? A simple 2-way interaction? What they mean is conditional, because the same rules apply. Beta 4 is describing how X moderates Z when W is 0, because that's the point at which X and Z are still in here, and the interaction would go away if the third thing is 0. So in this model, each 2-way interaction is conditional on the third thing, not in it, being 0. The 3-way interaction then works on the 2 ways. So beta 7 changes the X by Z interaction as a function of W, or it changes the W by Z as a function of X, or it changes the X by W as a function of Z. And all 3 are correct. It's up to you to how to tell the story. So what I would typically do to try and explain something like that would to be a figure with 2 panels. And I'd have, like, low W, high W, and then I'd have lines for X and Z to show the patterns of the 2-way and talk about how this pattern is different than that pattern. So it is possible to be able to do this. It just takes a little bit of thought and focus. But here's the rules. So the effect of W, pull all the things out that have W in them, factor W out, and here's the roots of what's left. So beta 1 is the effect of W when everything else drops out, when all the moderators are 0. Beta 5 turns up or down the effect of W. Beta 6 turns up or down the effect of W, and then they do it together in beta 7. And then the model implied conditional two ways would be like this.
Okay, so in simple terms.
Simple
we're taking
terms.
Betas 4 through 6
Mhm.
to make an interpretation around the three-way interaction, which is beta 7.
Yep. Yes, exactly right. So the two ways change the main effects, the three ways change the two ways. Can you think what a four-way would do? Change the three ways, which then change the two ways, which then change the slopes, which then change y. It's like trickle down. The vision that I have in my head for this, by the way, is Plinko. I'm not sure if this means anything to you.
Bob Barker.
Bob
Multiple
Barker,
shifts.
yes, the Price is Right. That show has been on for decades. That was like Gen X people like myself, when we were sick home from school, we watched The Price is Right. It was a universal phenomenon. We ate saltine crackers, drank 7-Up, and watched The Price is Right. That was how you dealt with illness in the 80s. But they have this game called Plinko, and it's a pegboard, essentially, with just enough room for little discs to slide around it. And the question is, where are the discs going to land at the bottom of the board? So I think of this as like the top of the Plinko board is like the three-way interactions, and they come down and bounce the two-way interactions, and they come down and bounce the main effect interactions, and then they come down and land on Y. Does that help? They're like, no, just stop it. I'm trying. Can I get points for trying at least? There. How about a summary? And no more equations, since it's 3:05. No more equations for today, okay? There will be many equations throughout this semester, but my job is to explain them so that they're not just foreign language, which math can honestly be. So, big picture.
Question before
Yeah, go
we
ahead.
go on to that.
Please.
So interactions tell us that two things occur together, or three things occur together, four things.
No, I would not put it that way. So the suggestion was, do interactions tell us how two things occur together? That to me sounds like a correlation between the two things. I would say they tell you whether this relationship holds for everyone or whether it's different for different kinds of people. So can I borrow your example that we were talking about? So she came at office hours for a study where students are doing writing of some kind, and they're given 4 different tasks of writing to do, and this happened for 2 different kinds of topics. So each student only wrote about one topic, but they did 4 things with it. So then the question is, some of these tasks, what's your outcome? Can you give me one of the outcomes?
How much they plagiarized.
Oh, okay, cool. So plagiarism. Plagiarism might be more likely in some tasks than others, right? If you have to write something about, like, what happened in World War II, and you can go ask ChatGPT about that, as opposed to, tell me your favorite memory from your childhood. ChatGPT ain't going to help you, or it's going to lie and hallucinate, but it's not going to help you. So plagiarism is more likely in some tasks. It does hallucinate. It makes stuff up. So you'll have task differences, and some tasks lend themselves to plagiarism more. Okay. But does that depend on what you're writing about? Like in my example, right? If you're writing about a memory versus something else, then the topic might matter. So you're looking to say whether all tasks lead to plagiarism, or sometimes they don't. Does that help? Okay. Anyone else want to give me an example and get some free consultation? That's what this is. You know, people pay me.
How do interactions differ between like a hierarchical linear?
Hierarchical linear model means 2 different things depending on your context. Are you talking about like models for like kids nested in schools, nested in districts? Or are you talking about regression models where you have some stuff and you add another layer of stuff and you add another layer of stuff? They don't necessarily relate to it, but they do in practice in the way people use them. So what I often see is a main effects model as one layer, and then they'll add in interaction terms as a second layer, and then focus on what the interaction terms did above and beyond. It's like how strong the moderation is.
Okay.
If you do that, that's fine, but do not forget to put the main effects in the interaction model and to interpret them. So many years ago, there was a APA style manual that had an example table from hierarchical regression that's flat out wrong. Because what they told folks to do was report the main effects from the main effects only model and then only report the new terms. Yeah, that
They
face,
fit
exactly.
together.
They go together, exactly, because whoever wrote the APA manual doesn't understand regression. So you can't refer back to the values from the other model because they don't mean the same thing. The ones from your new model are specific to 0. And you got to know what that is in order to think about the effects becoming stronger or weaker. Okay, did that help answer your question? If you're talking about the other kind of model, like kids nested in schools and districts, everything turns out to be an interaction term in those models. And all of this still holds. They're just more complicated in terms of their residual structure. So yes, we're talking about moderation. See if I can wrap this up quickly. The main effect slopes will change once predictors are part of an interaction because they're conditional. They mean something different. And that's why I'm focusing on centering so that 0 means something, because you don't want to have a simple main effect conditional on can't happen. That's not very useful. Rules for interpreting: intercepts are always conditional on the main effects. So the intercept is always the expected value when the predictors are 0. Adding interaction terms among your predictors does not change that interpretation. Main effects are conditional on 2 ways. 2 ways are conditional on 3 ways. 3 ways be conditional on 4 ways. And the highest order term is unconditional. There. That is the end of lecture 1 for real.
Yay.
And that was almost perfectly timed because it's 3:10. That means we get to do lecture 2 next time, which is transitioning into generalized models. So the actual name of the class. Binary outcomes first because they are the easiest, and then we add additional complexity. So what makes this hard is not anything that I just talked about. It's figuring out what y is in these models. Because there are 3 different scales for y that you will see across output and notation. That's what makes this hard. So we'll remove our focus on interaction terms for a little bit and refocus on the y side. Okay, questions or comments?
Question.
Yes.
So,
and then you.
with the interaction terms,
Mhm.
the one with the most interactions would also be the only one that would be unique marginal? Is that correct? Or not necessarily?
The highest order interaction term is marginal. That you
Right.
can say for sure.
Okay.
But the other things depend on if they're part of interactions or not. But highest order is always unconditional or marginal.
Can I share a visual picture that's trying to help me get conditional and marginal straight?
Okay?
So I'm thinking something's conditional, so it only applies to one element in the study. When something is marginal, it goes from one margin of the paper to the other. And what I keep thinking in my head is from C to shining C. It affects everything in the model if it's marginal.
Yes, marginal is from C to shining C.
Thank you.
Yep. And conditional is nope, right here in Iowa City. It's true in Iowa City. I don't know if it's true in the shining C. So we start by assuming that it's C to shining C, and then we would say, really? Maybe they do it differently other places. So I like that. It works. Okay, good.
I'm glad it's not false.
Yeah, I like it. It works. Did you have a comment too?
I have a question.
Question, okay.
Can you remind us again the difference between the general and generalized model?
Yes. General actually means something very specific. It means a model predicting an outcome whose residuals are supposed to be normal. Generalized is predicting any other kind of outcome. So generalized means not normal, broadly construed. All right, then 312. Thanks for being here. We'll call it a day. And I hope to see folks on Thursday. Let me know if you need anything. And you can start working on your formative assessment.
Mm-hmm.
All right. Bye for now. Thanks, Zoomers. Thanks, Roomers.